So, to deal with such tools, what I'm uh, about to do is just I'll give you some basics, fundamentals of electric circuits. Frankly, we don't require all this right now. Actually, after current electricity chapter, we might require. But the issue is I cannot wait till that point. Some questions will be given on the basis of these areas. So therefore, um, we will work on like this. The first thing, it is like Kirchhoff current law type. See, for example, you have any circuit. What I am dealing with is a junction. This is some junction. Junction. Capacitor C1, capacitor C2, capacitor C3. Remember, this is a portion. What is that I am showing you is a portion of a large network or circuit. Let this point be P. Remember, P is isolated, which means not connected to earth and not connected to battery. Hmm. So that is the meaning of isolated. For example, at some point of time, let the charge here is minus Q1 plus Q2 minus Q2 plus Q3 minus Q. Then this zone net charge is 0 because P is isolated, which means minus Q1 plus Q2 plus Q3 is equal to 0. That is a current law here applying for charge, static charge. Any student having doubt on this, please ask. This is Kirchhoff current law. Okay. So you will use this as a tool to solve some circuits. Similarly, another law which I am about to deal right now is Kirchhoff loop law. For example, for this purpose, you require a closed loop. Imagine a simple closed loop over here. Let the capacitance here be C1, C2, C3. The voltage drop is V1, V2, V3. V volts. Now you choose points like this: A, B, C. Entire thing is C. So what Kirchhoff law states, that is, what is VA minus VB? Simply V1. This you can write as Q by C1. VB minus VC is V2. Q by C2. VC minus VD is V3, which you can write it as Q by C3. VD minus VA is minus V. Why? Why it is minus V? Minus 2 plus you are right. So therefore, now the loop is closed. You take the sum of all these things, you get 0 here, which you will write it as V1 plus V2 plus V3 minus V, and therefore Q by C1 plus Q by C2 plus Q by C3 minus V is equal to 0. This is the loop rule which you will apply. Okay, to solve some circuits, ఒరే నువ్వు జుట్టు దులుపుకోవటమే అవుతుంది, బొర్రకేమి ఎక్కించుకొని సావటం. That is the loop. Till this point, any doubt? Have you followed? Clear? Right. So you will find some circuits like this. Like wherever it is required, I will apply. Next. Another question, another application which I might do. Another application which I might do might be what you call nodal method. See, I am telling you again, I will use all these things when and where it is required. That doesn't mean you should apply everything. When you have a chemistry lab, in chemistry lab, you will have some racks and liquids. That doesn't mean whenever you go for a chemistry lab, you should use all the bottles in that rack. So when and where it is required, I will use. There is another rule also, that is Wheatstone's bridge type circuit. Now, for this purpose, you will see the arrangement like this. You will see the arrangement like this. Exactly like this. See, please try to understand. In this, you label it as A, B, C, and D. The capacitances are C1, C2, C3, C4, and C5. Now, say some charge Q enters when connected to a battery. Now, in this case, Q1 is the charge over here, Q2 is the charge over here. Okay. Similarly, Q3 is the charge over here, Q4 is the charge over here, Q5 is the charge over here. Then what do the last states? B is an isolated part. This is an isolated part because I am not connecting B to earth. I'm not connecting B to any battery. So therefore, in this case, minus Q1 plus Q3 plus Q5 is equal to 0. Similarly, you should identify another such isolated portion. For this isolated portion, you can see minus Q5 minus Q2 plus Q4 is equal to 0. See, C1, C2, C3, C4 can be adjusted in such a way that if C1, C2, C3, C4 can be adjusted such that VB minus VD is equal to 0. There is no potential difference there. You know what happens in that case? In that case, the circuit will tend to a form like this, simply like this. Simply like this. Simply like this. C1, C2, C3, C. Whatever in between BD, I have removed. Why? Potential difference is 0. Nothing flows through that. So in this case, what will happen, it is the same charge. Now in this case, Q5 becomes 0. Q1, Q5 becomes 0. And therefore, when Q5 becomes 0, Q1 becomes the same as Q3 and Q2 same as Q4, same charge. In such a case, VA minus VB is equal to Q1 by C1. VB minus VC is equal to Q1 by C3 because you said Q1 and Q3 are same. Next. Similarly, VA minus VD is Q2 by C2. VD minus VC is Q2 by C4. From this, I can say, okay, from this, and you already know, VA minus VB is the same as VA minus VD. So VA minus VB is the same as VA minus VD. Similarly, VB minus VC is the same as VD minus VC. I repeat, VA minus VB is the same as VB minus VC. Right. But there is no confusion here. 1 minute. I repeat again. VA minus VB is the same as VA minus VD because PA. How? Why VA minus VB is same as VA minus VD? Tell me. Because VB is equal to VD. We have adjusted like that. C1, C2, C3, C4 values. Similarly, VB minus VC is the same as VD minus VC. Right. Now this implies Q1 by C1 is equal to Q2 by C2. And this implies Q1 by C3 is equal to Q2 by C4. Let this be equation 1 and let this be equation 2. If I do equation 1 by equation 2 properly, I'll get C3 by C1 is equal to C4 by C2. This is the condition balanced state condition of Wheatstone's bridge. Okay. Remember, this is all true under only one condition. What is that? VB is equal to VD. Only then it is correct. Till this point, any doubt? Very clear? Next, another circuit tool is also required, and that is called nodal method. Nodal method is another circuit tool. I don't see this any different thing from what I have suggested earlier. It is as same as actually Kirchhoff current law, junction. But yeah, when and where it is required, we will use. Like for example, you take an arrangement like this. This is Chapandi. 10 volt. This is 2 microfarad. This is 4 microfarad. This is 4 microfarad. And this is a 2 microfarad. And again, remember, this is not Wheatstone's bridge condition. Notice, this is not Wheatstone's bridge condition. Why? Because C1 by C2 is not same as C3 by C4. So A and B will have different potential. A minus B is not 0. This point A and this point B is not 0 in this case. Then how to do this model? We have something called nodal method. Node means a junction we will take as a reference. Now I am taking A as a node. Let the potential be X volt here. Let the potential be Y volt here. Right? I'm assuming it like that. Here, at node A, net charge is 0. Means I will take that voltage itself as the final thing. And imagine for this purpose, especially, you should take one point in the circuit as 0 volts. I have suggested that this point I will take as 0 volt. Nodal method, this is very important step. One point you will take it as 0 volt. The other point you will take it as 10 volt. And the entire point is P volt forever. The entire line is P volt. Till this point, any doubt? Now what is happening? Now if I am taking A as a node, see VA minus VP times 4 microfarad is the charge on that plate. Yes or no? Charge on which plate? Charge on this plate. That is that nodal method condition. You have anything wrong, you just tell me. I am taking that as a reference. Finally, you want Vx minus Vy. That I will give. Okay. See, if not, why I require this method, then tell me. Already we have two methods. Right. Now the question is plus Vx minus 10 times 2 microfarad plus Vx minus Vy into 1 microfarad is a 0. That is taking that point A as a node. Any doubt? I repeat, please go through again. You please go through again. I have taken X as the node. The charge on this plate is Va minus Vp times 4. The charge on this plate is Va minus, remember, X itself is the top. When I am taking a node, X itself is a top. X itself is a top. Okay. So in this case, what I will write is it is yb actually. Now in this case, I am taking as X minus Vp times 4 plus X minus 10 times 2 plus X minus Y times 1 is equal to 0. You have two unknowns and only one equation. Then what is the other alternative I have? Now take B as a node again. Now take B as a node again. Yet node B. Now what will happen? Now again, you will simply follow the same logic. Y minus 0 times 4 plus Y minus X time 1 plus Y minus Vp times 2 microfarad is equal to 0. Right? So now you have two equations. You have two unknowns, solving which you will get X and Y. So that's all. No one will ask you what is X. Remember, they will ask you what is the charge on 1 microfarad. For that purpose, you require Vx minus Vy. If I say Vx as this, wrong, because as you said, nowhere it was given the point O is earthed. This point is earthed. Nowhere it was mentioned. Nowhere. Nowhere it is mentioned. So therefore, this method helps me to find Vx minus Vy. Of course, I will find X and Y, but basically I want Vx minus Vy. Different methods. Next, one more method, nodal method is the next symmetry of the circuit. Symmetry circuits. So one such example for that is this. You take one circuit like this. Such a circuit is called symmetric circuit. You see, you observe the circuit from A side or B side. It looks alike. Such a circuit is called symmetric circuit. In symmetric circuit, the principle is you will identify that suppose if Q1 charge goes by here, Q2 charge goes by here, Q1 charge goes by here, Q2 charge goes by here, you will again get Q1 here, Q2 here. That is the meaning of symmetric. Yes or no? See, ఏ దగ్గర Q1, Q2 బయలుదేరితే B దగ్గర అలా కలెక్ట్ కావాలి. లేదు B దగ్గర బయలుదేరితే Q1, Q2 ఏ దగ్గర అట్లా కలెక్ట్ కావాలి. Which means this point node, no splitting of charge takes place. No splitting of charge takes place. So such a line which you identify here is called potential divider. That line is called, on that line, every point is at the same potential. So along that line, potential is the same. So therefore, this circuit can be rewritten as remember, this is strictly allowed only for symmetric circuits. If you change one capacitor out of this, everything is gone. That's all. This circuit can be assumed to be of this form. Till this point, any doubt? Every student in the class. Clear? Got the point? Now then everything is known to you. Now C, 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 C. Now what is going to be this part? Tell me. What happens to this part? C by 2 plus C. Yes or no? C by 2 plus C becomes 3C by 2. So therefore, you will have C 3C by 2 C, and this will become C by 2. Till this point, any doubt? Now, what is the equivalent part of the above? 1 by C plus 2 by 3C plus 1 by C is 1 by C equivalent. So 3C is LCM, 3 plus 2 plus 3. 3C by 8. 3C by 8 and C by 2 are parallel. So therefore, finally, this will become 3C by 8 plus C by 2. 7C by 8. Equivalent across AB. So CAB is 7C by 8. Symmetric circuit. अरे यार ट्रस्ट में पूरा ऐसा ही होगा बस. Every flow of the circuit hereafter is going to be like this. Next comes infinite circuits. This model will come under infinite ladder. Infinite ladder models. Hold on. So, model by model, I am dealing with. Right. So, how to handle infinite circuits? The rule is, whether I cut the circuit from here or here, almost it is the same value because infinite minus very small quantity. Any doubt till this point? So therefore, what I am going to do is, this is all C equivalent. Now I will modify my circuit into this format. A 1 microfarad, B 2 microfarad, and it is nothing but C. What if I ask across AB the circuit? This is also C equivalent. Actually, if I question you here only, it is C equivalent. Any doubt in that? Please ask me right now. I forget about that highlighted part. Otherwise, if I ask you what is the effective capacity across AB, you will say C equivalent. If I remove first 1 microfarad, second, first 2 microfarad also, you will say C equivalent because it is infinite later. Right. Now, what is going to happen is 2 microfarad C equivalent in series. So, therefore, 2 into C equivalent by 2 plus C equivalent plus 1 microfarad. And this is again C equivalent. Have you followed this step? This step, this is in series combination, and this is the value of series equivalent plus this one, 1 microfarad. Now, what is going to happen from here? So, this will become 2 times C equivalent by 2 plus C equivalent is equal to C equivalent minus 1. 2 times C equivalent is C equivalent minus 1 into C equivalent plus 2. So 2 times C equivalent is C equivalent square plus 2 times C equivalent minus C equivalent minus 2. This implies C equivalent square plus 2 times C equivalent, no, X 1 C equivalent plus only, plus C equivalent, yes, minus C equivalent minus 2 is equal to 0. Now it's a quadratic. Now C equivalent is 1 plus or minus root of B square plus 8, 4 2s are by 2. So this will be 1 plus 3, 2, because it can't be 1 minus 3 by 2. So what is this going to be? 2 microfarad. Minus 1, it is not possible. Minus term is not possible. This is how you will handle infinite ladder. Now, the basic 4 models which you are about to face, I have discussed. Now, tell me if you have any doubt on till now whatever covered. Infinite models, you have any doubt? Ask me right now. Any student in this class, do you have doubt in understanding that? Are we clear? Right. Now, today's models we will take up. Now, you start with this. Everyone work on this. You have an infinite ladder which is constructed by connecting several sections of 2 microfarad, 4 microfarad. You can see that. It is terminated by a capacitance of capacitance C. What value should be chosen for C such that the equivalent capacitance of the ladder between A and become independent of the number of sections in between? Now, try to please understand the equivalent capacitance of this given infinite ladder between A and B becomes independent of number of units in between. This is what they want. Yes or no? Paka? What does that means? The meaning is, if we remove, okay, if we remove all the capacitors, I repeat, if we remove all the capacitors other than terminal capacitor C, I'm repeating again, listen carefully. The meaning of equivalent capacitance of the given infinite ladder between A and B becomes independent of the number of units in between. Means, if we remove all the capacitors, right, other than terminal capacitor C, right, the equivalent capacitance, okay, the equivalent capacitance across AB should also be C. That's it. So what does that means? Now you have the arrangement. You have this arrangement, 4 microfarad and a 2 microfarad. And you have the arrangement for a while, say A dash, B dash, the last one, 2 microfarad, 4 microfarad, C. This is the arrangement, right? So now you will handle this as, this part as some C equivalent dash. So C equivalent dash is equal to 2 plus 4 into C by 4 plus C. Agreed? And that should be C. That's what I do. That should be C. Now, otherwise, I cannot solve. I should use the data as it is. Now, by solving which, you will get the equation as 4C by 4 plus C is C minus 2. C is equal to 4 microfarad. By using C as 4 microfarad, you can achieve this condition. Any doubt? Pakka? Next, 1 minute. One more question is there. Now try this question. Find the EMF of the battery. Assume that before connecting the battery in the circuit, all the capacitors were unchanged, uncharged, neutral. Neutral. Okay, fine. Now I will analyze this properly. I will analyze this properly. Now I see that. Now I see that in this is one wing. This is another wing. This is all another wing. Agreed? Have you seen the circuit in the same way that what I have observed? Right. Now then tell me, this is a 4.5 microfarad. Ten microfarad, 30 microfarad. What is this going to be equal to? Are 30, 10, 30 by 40, 30 into 10 by 30 plus 10, 40, 30 by 4, 15 by 2, 7.5. 7.5 plus 4.5 is equal to, so across A, D, it is 12 microfarad. Right. Now, similarly, across AC, you have across AC, you have 12 microfarad, 6 microfarad. And this is equivalent to how much? AC, 4 microfarad. Right. So I am building up elements. Don't forget that. Right side, nothing to worry. Now, battery, D, boys and girls, A, in between you will have 12 microfarad. And by the way, AC is 4 microfarad. Above you have 6 microfarad actually. Frankly speaking, you should do that like this, 6 microfarad. And this is a 10 microfarad. Correct, Aga? So this is 10 microfarad. Ends at C. 5 microfarad. Right. Hold on. That's what you have the circuit. Right. Now again go back. You said 4 volts here. You said 4 volts here. This is a 12 microfarad. And this is a 6 microfarad. Are here 12 microfarad, 4 volts means charge is CV 48. It should be the same charge at 6 microfarad because they are in series. So which means how much? 48 by 6. 8 volts. Now I have understood one point. Across this combination, you have a total potential drop of how much? 12 volts. Then what was the charge driven in the circuit? Q is equal to CV. 10 into 12, 120 microcoulomb. So therefore, here also the charge is the same, 120 microcoulomb. So which means the drop here is 10 volt. Now, what is going to be the drop here? 120 by 5. 24 volts. Now I got the point. So the total EMF is 10 plus 12 plus 24. How much is this? The total value of that arrangement is 46 volt. So please try to understand. I haven't done any mistake at any level. I just done basic understanding of the question. So I have reduced this entire circuit to this form. But meanwhile, I have understood across AC what is the potential drop. Across AC, the potential drop is clearly 12 volt. This is the life of the question. Any doubts? Boys and girls? Right. Now, I try this. 1 minute. Yes. Try this question. So you need to do this model by which method? Tell me. Nodal analysis. Correct. So for this purpose, you should define nodes, right? So suggest me what points we will choose as nodes. We will take this as X. We will take this as Y. And one more important rule also we have. What is that? You require a 0 volt point. Which point you will take it as 0 volt? Code. Means this is also 0 volt. The moment you accepted this as 0 volt, this will become plus 10 volt. This will become plus 5 volt. If this is plus 5 volt, this will become plus 10 volt. No, hold on. Hold. X neighborhood, left side you know voltage, right side you are about to know Y, bottom you have 0. So X no issues. X no issues. But please remember, for one node, you will have 3 different potential or 4 different potential. 3 you must know, fourth one is unknown. Right? If there are 3 junctions around our node, 2 you need to know, 1 you need to find. అప్పుడే కదా 2 ఈక్వేషన్స్ వచ్చేది. Right. Now starts. Now for X as a node, X as a node, X minus 10 times 2 plus X minus 0 times 2 plus X, always X first, 0. Okay. Equation 1 at X as node. Now, can you please help me in finishing this? 2x, 2x, 4x, 8x, minus 4y, minus 20 is equal to 0. Boys and girls, are we clear? Now, yet y as a node. Yes, help me. Y minus x into 4 plus y minus 10, y minus 10 into 4 plus y minus 5 into 2 is equal to 0. Equation 2. Now tell me, complete this. 4y, 4y, 2y, 10y minus 4x minus 40 minus 10 is equal to 0. Right. So how to eliminate this? One thing is clear. Equation 1 plus 2 times equation 2 we will take. So in that case, 8x minus 4y is equal to 20. 20y minus 8x is 100. Now you add in the process of addition, cancel. 16y is 120, implies y is 120 by 16, 15 by 2 volt. Right. Use x, use the value of y in any of the equations. Implies equation 1 implies 8x minus 4y. 4y means 30. Minus 20 is equal to 0. X is equal to 25 by 4 volt. Array, X ఇచ్చేసా, Y ఇచ్చేసా. You find whatever you want. Right? Any doubts? Clear? Pakka? Otherwise, you need to apply Kirchhoff's second law. For left one loop, middle one loop, right extreme one loop, likewise. So which is lengthy process. This is relatively slower, lower process. 2 steps. Honestly, if you are not compromising, you will win. If you are compromising, then I cannot help you on this. Try to please understand. If you have any doubt anywhere, feel free to ask. Clear? I'm not convinced still. I'll give one more model. Do this. So similarly, by going with the same equations, like how the way we have done, you will get x minus 10 times 2 plus x minus 0 times 2 plus x minus y times 4 is equal to 0. Similarly, you will apply for y minus x times 4 plus y minus 5 times 2 plus y minus 15 times 4 is equal to 0, solving which you will get that relation. Right. So you know how to do nodal method. And I'll go with the next method. Next method is I'm giving you, this is a pathfinder question. Easy question only. Try this. Your skill lies in understanding the question properly. Your skill lies in understanding the question properly. So there is a term given as right. So we will take 0 volts. What should be the terminal voltage of the battery? Say we will call this as 0 and this as V. V not already taken, so what should be the terminal voltage of the battery connected at the rightmost end so that the potential of nodes 1, 2, 3, 4, 5, 6 geometric progression. What is the meaning of geometric progression? If I am taking V1 as V naught, V2 must be R V naught, common ratio. V3 must be R square V naught. V4 must be R cube V naught. V5 must be R power 4 V naught. V6 must be R power 6 V naught, which is nothing but R power 5 V naught, which is nothing but your V. Right, hold on. Now, if you allow me, I will take junction 2. This junction I will take. This is connected to here. V naught, R square V naught, R V naught. Agreed? So I can apply C1, C2, C1. Nodal method here. Nodal method here suggests me that RV naught minus 0 times C2 plus RV naught minus V naught times C1 plus RV naught minus R square V naught times C1 is equal to 0. Rewrite this properly. RV naught C2 plus R minus 1 V naught C1 plus R minus R square V naught times C1 is equal to 0. Here I can do two things. I need to remind C2 by C1 as 4 by 3. And I can eliminate V naught everywhere. Now what I am going to get is R C2 by C1 plus R minus 1 plus Y V naught. R minus R square is equal to 0. Now you will get a quadratic equation. Now that quadratic equation leads to 3R square minus 10R plus 3 is equal to 0. Now by solving this quadratic equation, you will get two roots. R is 10 plus R minus root of B square. 100 minus 36 by 6. So this leads to 3 or 1 by 3. Anything is possible. So therefore, we can take two layers. One is 3 power 5 V naught or 1 by 3 power 5 V naught. Anything is possible. Okay? Do you got this point? Right. So this is anywhere you still have doubt, please ask me. What is the skill involved in solving this question? Anyone please help me? understanding the question properly, decoding the data given in the question properly. These are the features involved in solving this question. Where will we fail? In decoding the question properly, we will usually fail. Got the point? Clear? Okay, next models. Now, this is arranging parallel plates into an equivalent capacitor. This is very famous one. Mostly with this, we will almost the theory is done. Almost the theory is done. Only thing required is practice. Now, how to handle problems of this type? Right. So, different teachers will have different way of writing this. My technique is I will label phases 2, 3, 4, 5, 6, 7, 8. So I have labeled. Where to start with? You take this as a positive terminal. You take this as negative terminal. Now, when I start with A, now I will have plates names also you should write. A, B, C, D, names of the plates. Now I'll take plate B. Plate B, 3 facing. Plate B, 4 facing. Any doubt? Now what is opposite to 3? 2. And 1 is open to sky. No issues. Nothing is sharing there. What is opposite to 4? 5. Of course, this is your positive plate. Right. Now, plate C. This is plate C. 6 is facing what? 7. 8 open to sky. Now again, plate A is this. 1, 2 is connected to 5, 6. 1, 2 is connected to 5, 6. And 7, 8 is connected to negative terminal of the battery. My circuit is done. I have completed the circuit. All the gaps are D only. So each capacitor is epsilon naught A by D. Now, first thing, check where is plate A. Where is plate A? This is plate A. Where is plate B? This is plate B. Where is plate C? This is plate C. Where is plate D? This is the plate D. When an account close chesana, I am showing you full account. Now finally, how can I write this further? This is simply C, C, C. So nothing but 2C and C series. 2C by 3. This is the, antega, 2C by 3 is the equivalent capacitance of the arrangement. Any doubt? Boys and girls, Pakka. If you have really understood this, then try this. Are they same or different? Then don't try this. Try this. Try this. But in this question, answer is not 2c by 3. 2 by 3 epsilon not a by t. Because they haven't given anything about c. Out of all, this is the most easiest case. Most easiest case. You don't use any term called C here. Don't use any term called here. You define better what is C initially. I am defining C as some term which is epsilon not A by T. Now we will label 1, 2, 3, 4, 5, 6, 7, 8. Best thing is nothing stays between 4 and 5 because they are short circuited. Why? Now what is happening here? A is the first plate, followed by plate 2, 3, followed by 6, 7. Nothing, you short circuited these two plates. So therefore, any charge if stores, it stores like this. It stores like this. So it is now, first part is a C. If it is a 3D, this is a C by 3. C by 3 is series. So this is equivalent to C by 4, which is nothing but epsilon naught A by 4D. So that you need to identify. It's an easy question actually. When compared to the previous one, it's an easy question. But still, if you have any doubt, ask me. Boys and girls. Do you have any doubt in this? Well, I have placed some more questions. Yes. Now, this is a challenge for you. Honestly, this is a good question. Tomorrow, I'll discuss completely different end problems, switch models. May I start? Time is a criteria. You better practice. See, we will take plate 1, 2, 3, 4. Already they have given. Now see, always start with the positive plate. I said. Now you start with the positive plate. So I have started with the positive plate. Now A. A is this is the plate 3. This is also the plate 3. Now 3 is facing 2. This is all plate 2. And again 2 is facing 1. This is all plate 1. Okay, upper side is done. And on the lower side, 3 is facing 4. Okay. Now, 3 is facing 4 undoubtedly. And 4 is facing, the entire thing is plate 4. 4 is facing what? 5. And 5 is connected to negative terminal. And this is connected to positive terminal. Now it is still incomplete. Now I have identified plate 3, I have identified plate 2, identified plate 4. 1 and 4 were connected. 1 and 4 were connected. Now you please take the account. First, plate 1 identified, plate 2 identified. Plate 2 will have 2 faces sharing charge. Yes. Plate 3, 2 faces sharing charge. Identified. Plate 4. This is a total plate 4. This is a total plate 5. Now what is happening? That's the circuit. Done. What happens is you just identify all are epsilon naught A by D only. Equivalent capacity is, just please roughly tell me C by 2 C series. C by 2 C series. No. C by 2 C parallel. What is that? 3C by 2C series. What is the equivalent? 3C by 2. It is now 3C by 2 into C by 5C by 2. This will become 3C by 5. So equivalent capacity is 3 by 5 times epsilon naught A by D. So B is correct. Right. Now charges. Simple. Now hold on. I'm writing the next stage of the circuit. The next stage of the circuit is 3C by 2 C connected to the battery V volt. Yes or no? So now the question is, now this point and this point is X, this point is Y, this point is Z. X, Y, Z. Right. Now how is the capacitance ratio? Now here I am taking the voltage drop as V1, the voltage drop as V2. V1 is to V2 is reciprocal of capacitors, I told already yesterday. So 1 by 3C by 2 is to 1 by C. This is nothing but 2 is to 3. So therefore, what is going to be the drop across Vx minus Vy is 2 by 5. Vy minus Vz is 3V by 5. Done. Now you want the charges. Hold on. Now across this combination, you will have, you will have 2V by 5. across this combination. Across this combination, you will have 3V by 5. Aha, okay. What is the charge? What is the charge on the plate 1? No issues. You want the charge on the plate 1, right? Again, if you further zoom this, you said 2V by 5. Both are same capacity, right? So therefore, you will have V by 5 here, V by 5 here. So therefore, at one charge is at one charge is Q is equal to CB kada. CB by 5, which means epsilon naught A by 5D times V. Correct. Charge on plate 3. Total, total charge on the plate 3 is how much? See, here you will have a charge of plus epsilon naught A by 5 dV. What about the charge at this point? Charge at this point. What about the charge at that point? Here total drop is total drop is 2V by 5 there. Entire 2V by 5 drop is there. So therefore this will become 2 epsilon naught A by 5 dV. Now tell me what is the total charge? Total charge on plate 3 is epsilon naught A by 5 dV plus 2 epsilon naught A by 5 dV. This will become 3 epsilon naught A by 5 dV. Correct. Now, you have any objection, any observation, any doubt, ask me now. When I will usually tell the mistake. Yesterday also one student here, parent arrived here. I spoke to her. He was just telling, I have doubt, but I have hesitated to ask him. Please try to understand. I am giving this much space in between every question. I am giving this much space. The purpose is you must question me. He was asking why 0. I have explained properly. Thereafter, the next question, nodal method, you have clearly followed that question. Yes or no? No, you should ask me now. Now, what will happen thereafter? If you are stacking those doubts with you, that will create a big vacuum. Any doubt till this point? Pakka? Sure? Everyone followed this confidently? If you really followed this confidently, I'll give you another question. This is the question. Try to do this question. Hope you are doing this. Now tell me, now in this case, figure show 4 plates, each of plate area A, separated between plates is D. The separation between each plate is D. There are 2 switches above and below, 2 batteries. Now you have closed SW1 and SW2. There you are closing SW2 makes nothing because shorted, literally shorted. It is as same as connecting 1-3. So try to please understand when both are closed, both switches are closed, the actual plate structure becomes And with SW2 closed means that's there. That is the arrangement. You got a point? Now you know how to do this question. Now it is like the positive plate will become 2 now. Plate 2, plate 2, opposite to plate 2, you have plate 1, and opposite to plate 2, you have plate 3, and 3 is again opposite to 4. 4 is connected to the negative terminal, and 1 and 3 are connected like this. 1 and 3 are connected like this. That's all. I think you can clearly understand what is going to be the circuit now. This is nothing but 2C C plus minus. So what is the C equivalent? 2C by 3. So therefore, switch, what is the charge on plate 2 is what they're asking. Hold on. First, what is the charge drawn? No. By the way, C equivalent is to C by 3. That is okay, fine. I think they are not asking anything related to that. Fine. Okay. Now, the question is 2C and C. Therefore, what about potential drops? What about the potential drops? V by 3 2V by 3. Because capacities are in the ratio 2:1, potential difference are in the ratio 1:2. So therefore, V by 3, 2V by 3. Now, here across this combination, you have V by 3. Yes or no? Now, what is going to be the charge here? What is going to be the charge here? Epsilon naught A by 3D. 3dV. What is about the charge on this? Epsilon naught A by 3dV. Now when both are closed, what is the charge on plate 2? Where is plate 2? Yeah, plate 2 contains epsilon naught A by AV by 3D plus epsilon naught AV by 3D. That is totally 2 epsilon naught AV by 3D. Any doubt? Right. The two switches can activate two batteries in the circuit. By the way, V is also given. So what is that? What is that they have given is 2 epsilon naught A by 3D times 2V. Correct? Right. Any doubts? Boys and girls? Next. What is the charge passing through battery 1? That is okay. What is the equivalent capacity? Just now I have identified. From battery 1, C equivalent is 2C by 3. So what charge will flow through? Charge that passes through the battery is 2V, which is nothing but 4CV by 3. But there is no C term here. 4 by 3 epsilon naught A by dV. So therefore, for 31, the answer is 4. Okay. Till this point, any doubt? Now SW2 is opened. When you open SW2, circuit is different again. With SW2 open, what is going to be the circuit? Now with switch open, you have nothing to connect 1 and 3 now. When there is no connection between 1 and 3, this is how you are connecting. This is how you are connecting. Yes or no? So what is the role of this part? Nothing. Will there be any sharing of charge here? Now what is going to be what is the charge on plate 4? 4 plate means negative. Oh yes, tell me. Now you again write this properly. What are the numbers? 1, 2, 3, 4. 1, 2, 3, 4. Now again you have 2. You have 2. 2 is facing 1. Hoya. Again 2 is facing 3. 3, 4 are same. One has nothing to do, nowhere connecting with any part of the circuit. Now 4 is facing at the 4. No, hold on 1 minute. This is still 3. 3 is facing 4 and 4 is connected to negative terminal. Yes or no? Right. Now this is 3. Now this is plus. What is the effective capacitance now? C by 2. Plus C by 2. Because 1 is open. It has nothing to do with any part of the circuit. ఇలా ఉంటుంది open circuit కదా. This is the open circuit. It has nothing to do with any part of the circuit. C by 2 across the combination. Now tell me what is the potential drop? Here it is V by 2. Here it is actually వాడు ఏమి ఇచ్చాడు రాడు 2V ఇచ్చాడు కాబట్టి I should say V and V. What is the charge on plate 4? Charge on plate 4 is now it is V. Now it should be. And I have done one more mistake. And that mistake is 1 and 3 open, no? 1 and 3 open, right? Oh God, hold on. In fact, this is incomplete circuit. You open the switch means you are connecting another battery here. You are connecting another battery here between what and what? Between 1 and 3. That is the circuit. That's the circuit exactly. So you rewrite this properly. This is a very confusing way of writing. Okay. This is one circuit. Remember, don't forget, this is a 2, this is 1. Again, this is a 2, this is a 3. Again, this is a 3, this is 4. Right. And you are connecting these again with battery like this. And remember, this is V volt and this is 2V volts. Now tell me what is happening. Now both one nodal method I don't suggest because practically that will trouble you. Practically that will trouble you. Right. Okay. We will do one thing. You do as a loop rules. You do the problem as a loop rule. I am further stretching out this circuit. This one, I am further stretching out to one battery, two, three, four, three. This is how you have the circuit. Remember, this is a 2 volt and this is V volt. I am assuming this will send a charge Q1 and this will send a charge Q2. Okay. This will send a charge Q1 and that will send a charge Q2. Right. Good. Now, what is going to be the charge at this point? Again, this will go as a Q1. Now, what is this charge? Q2 minus Q1. Now, you take this as a loop 1. You take this as loop 2. Right. Now, I am applying Kirchhoff voltage law for loop 1. Right. Now, Q2 minus Q1 by C. C means this part. Right. Plus. You are having Q2 here. Means minus Q2 by C minus 2V is equal to 0. Any doubts? Boys and girls. Any doubts? So I have applied what? Kirchhoff voltage law. Next. Now I am applying Kirchhoff voltage law for loop 2. Now when I am taking a loop, I am going in this direction. Right. Help me in writing this. Q1 by C minus V minus Q2 minus Q1 by C is equal to 0. Have you understood the signs properly? See, I am assuming this is positive and this is negative. So if I am facing the first negative terminal of a battery, I will write minus V. If I am facing negative plate of a capacitor, I will write minus of that charge by C. Now, help me in writing this properly. Cancel. Cancel. So minus Q1 by C minus 2V is equal to 0. Q1 is nothing but minus 2CV. Right. What about Q2? Substitute in any one of those equations. So therefore, Q1 by C can be written as minus 2V minus V, okay, minus Q2 by C plus Q1 by C. Plus Q1 by C, minus of minus is plus. Plus Q1 by C is again minus 2V is equal to 0. Any doubt? Sure? Yes. Pakka? Minus 2V minus V minus 2V minus 5V is equal to Q2 by C. So therefore Q2 is minus 5CV. అరే ఇప్పుడు ఇదంతా ఎవడు అడిగాడు మిమ్మల్ని అసలు ఏం అడిగారు క్వశ్చన్లో మిమ్మల్ని అడిగినది charge on plate 4. Where is plate 4 by the way? Where is plate 4? Plate 4 is this plate. Where is plate 4? Here. This plate. What is the charge on the plate 4? Plate 4 charge is Q2. Plate 4, the charge is minus Q2 actually. Hello, minus Q2. Charge on plate 4 is minus Q2. So plus 5 CV implies 5 times epsilon naught A by D into V. Any doubts? That's it. So that is the answer. Right. Any doubt, please ask me right now. Any doubt? ఏనా క్లియర్? అదే అందే దాందే ఉంది, మనకు వచ్చిందే కరెక్ట్. అన్ని త్రీలే ఉన్నాయి అందులో. ఆప్షన్లో అన్ని త్రీలే ఉన్నాయి. మనం చాలా క్లియర్గా ఎక్కడా మిస్టేక్ చేయకుండా వేసాం. రైట్. ఓకే, బట్ అయినా రేపు మీరు క్లాస్కి రాగానే ఇంకోసారి వర్క్ చేద్దాం. రైట్. Go to your